This is the review sheet for your test on exponentials and logarithms. So I hope walking through this problem by problem will help you. Feel free to skip around whatever ones you need help with. The written form of the answers are already there, so if you just want to see me work through one you had trouble with, feel free to skip to whatever one you need. First off, find the equation of the line tangent to natural log of x squared at 2, 4. Anytime we need the equation of a natural log, let me back up, the equation of a tangent line, there's two things we need. We need a slope and we need a point. And they gave us the point right out. It's 2, 4. So what we need to find is the slope, which as we know in calculus, we find the slope by taking the derivative. So our equation is the natural log of x squared. The derivative of that is the derivative of the inside over the inside. I'm going to go ahead and reduce that by canceling out an x and get that. But we want to know the slope at the point 2, 4, so I'm going to plug the 2 in for the x and find that the slope is equal to 1. So I have the point circled and I have the slope equal to 1. So I'm going to use the point slope form to then write the equation of the line. So I get y minus the y value equals m times x minus the x value. And on my test or the AP test, you can leave the answer in that form. They accept that. But you can also solve it for y if you want to. Just distribute the 1 and then add 4 to both sides. Number 2, we're told to take the derivative, and because of the form there, we'll need to use the product rule. So I'm going to write f is equal to 2 raised to the 4x, g is equal to x cubed. To take the derivative, it's itself times the derivative of the exponent times the natural log of our base, which is 2. And then g prime is 3x squared. So again, the derivative of 2 to the 4x, we did itself times the derivative of the exponent, which is 4, times the natural log of the base. So now I do f prime times g. So I'm going to do 4 natural log of 2 times x cubed times 2 to the 4x. So that's multiplying these pieces right here. And if you write yours in a different order, that's fine. It's all multiplying, so it's okay as long as you have all those pieces. Then we add f times g prime. Helps if I write that correctly. So that is, let me just rewrite that term, make sure we're clear. So the last part is f times g prime, so I have 2 to the 4x times 3x squared. Keep in mind, you cannot combine the 2 and the 3 because the 2 is the base of 2 to the 4x and the 3 is just a coefficient, so those do not combine. But this would be your final answer for that derivative. Number 3, we're asked to take an integral. We're going to use u substitution. And a reminder, when we just have one e, then our u is almost always going to be our exponent. When we have more than one e, then you'll need to think of things like e's that are inside a power, a radical, a denominator, trig function, something like that. But here we just have one e, so we'll make u equal to the denominator, x squared plus 2x. The derivative of that is 2x plus 2 dx. So to make that match x plus 1 dx, we'll need to divide both sides by 2. That gives us 1/2 integral of e to the u du. Antiderivative of e to the u is e to the u plus c. So we end with 1/2 e to the x squared plus 2x plus c. On number 4, we're told to take the derivative of this logarithm. And what we should do first here is use the properties of logs to separate this. So I will do log base 7, make sure you keep that base, of x minus 2 minus log base 7 of x squared plus 3. So then the derivative, we do 1 over the natural log of our base. Then we do the normal derivative of the inside over the inside. Minus 1 over natural log of our base. It's natural log of 7. And then the normal rule for log, or natural log, derivative of the inside over the inside. So really, it's the same rule as we would with a natural log, except for that coefficient of 1 over the natural log of the base, which was natural log of 7. So the one I just circled is one we completed right there, number 4. You could also factor out the 1 over natural log of 7 and put it all in front and have parentheses around the two pieces if you'd like. Either way would be fine. Number 5. We're told to find the derivative of this exponential. I'm going to first rewrite this exponential as 6x to the negative 2. And we know for the derivative of e, we do itself times the derivative of the exponent, which would be negative 12x to the negative 3. And that answer is completely fine for an open-ended question, but keep in mind they could simplify that by pulling the negative 12 out front. They might put the x squared back on the bottom right here, and this x to the negative 3 could also be written on the bottom as x cubed. So again, this first answer is completely fine. Nothing wrong with it at all. But if it's multiple choice, I want to make sure you know both of those circled answers are the same thing. Now number 6, we're finding an integral. In general, with integrals, we want to make u equal to the denominator. So u is x cubed minus 5, du is 3x squared dx. We will have to divide by 3 to make it match what we have. We get 1/3 du equals x squared dx. So when we substitute, we get 1/3 integral of du over u, which we know is 1/3 natural log of the absolute value of u plus c. So our final answer is 1/3 natural log absolute value of x cubed minus 5 plus c. Moving on to number 7, we're asked to find the derivative. Again, we want to use the properties first to make this simpler. We can rewrite the fourth root as an exponent of 1/4, and then I can move that 1/4 out front. That makes the derivative much simpler. Don't have to use the chain rule now. So when I take the derivative, I get the 1/4 out front. Then I do the derivative of the inside over the inside. And it's fine to leave your answer like this, but you could also distribute the 4 on the bottom. Again, I'd say for an open-ended question, both are pretty equal. Just be aware as far as multiple choice that this answer and, actually, I need to distribute the 4, so that should be a 12x right there. But once I correct that part, those two answers are the same. Now, in number 8, we're supposed to expand. I would recommend doing this in 2 steps. First, the multiplying that's happening on top can be rewritten as 2 logarithms being added together. And I'm going to go ahead and rewrite that square root as an exponent of 1/2. And then we're dividing the bottom, so we'll subtract the natural log of x plus 5 to the 7th. Then for our final step, we're going to move the exponents out front. So the first term doesn't change. The middle term, we put a 1/2 out front. And the last term, we move the 7 out front. So that is the answer to number 8. Last two, 9 and 10. Number 9, we're using the properties again, but we're moving in the opposite direction. We're condensing them. So first, got tripped over my tongue. I would do the same two steps we did in number 8, but in the opposite order. So I would first take the coefficients and move them up as exponents. And it's fine to write them as 1/3 and 1/2, or you could write them as a cube root and a square root. And then, combining it into one whole big logarithm, I see the first two I'm adding, so I would multiply the inside parts to make it a single logarithm. And the last piece I'm subtracting, so I'll divide that piece. And now it's all in one logarithm. Finally, number 10. Find the slope of the tangent line to the graph of y equals natural log of x squared at the point where x equals e squared. Notice they're not asking for the equation of the tangent line. They're asking for the slope of the tangent line. And as we learned way back in September, the slope of the tangent line is the derivative. So all we have to do is take the derivative of this equation and plug e squared in for x. So we get y prime is the derivative of the inside over the inside, which we can reduce to 2 over x. And then we just plug in e squared. So the answer is 2 over e squared. So notice, one like this, if it was on the AP test, they might be in a calculator inactive section. And if that's the case, they would expect you to just leave it as 2 over e squared. You wouldn't have to find the decimal. If it's calculator active, they may want you to find the decimal, but it'd be fine to leave the answer as 2 over e squared. Good luck on your test. Make sure you know your rules, and you'll be good to go.